I will post this so that everybody can see these questions again if you want to see them. So I've got some questions on here. All right, so we got trail walk questions, practice test questions. Awesome. So I think I'm going to do the practice test questions first. And if I have done, I did not mark them. So I've got these practice test questions, I think, up here already. So I'm going to go find a practice test. That was a trail walk, trail walk. All right, there's the practice test. So I'm going to delete all these. And let's start over with these. Looks like I did problem 4 for sure on the first one. All right, so we're going to do 9, 12, 10, and 4. So I'm going to start with number 4. So number 4 says, well, I tell you what, 4 is done on the first class. So I'm not going to spend time doing it again. So you can go to period 1 and find question 4 and watch that video, because this way we'll have more time to do other questions. So on page, it'll say period 1 questions over test review or something like that. I'm going to put it on remind. So you can go watch that for question 4. Question number 9. Okay, I did number 9 on the test as in the first class. The answer is E, but you can go on there and watch the video and see why it's E, because I explained that to them. Question 9, we did. Question 12, let's check it out. All right, 12, I don't believe we did 12. So use the function at the right to define the domain and range of the function. Well, there's no dot down here at the end, so that means this graph is going on in both directions forever. And because it's going on forever, domain always starts at the far left. So we have negative infinity. And I am way out here on this x-axis, way out here at negative infinity. And I am working my way back. And I'm coming along here, and this graph works all the way out there. It goes on forever. And as I'm coming in here, I see something happens right here. So the question I have to ask is, are either one of those dots filled in? And the answer is no, they're both open, which means that value doesn't work. So that value right there at -2 doesn't work. And then the graph goes this way all the way to infinity. So the only value that is not on this line is right here where it's got open circles at -2. So that means -2 does not work. So when I do this problem, I'm going to go from negative infinity to -2, and it didn't work because there was no dot there. And then I do a U or the word and I jump over -2. Remember, parentheses means it doesn't work. If it had a bracket, it means it works. So right there is my domain. So when I look up here at this thing, I know this one's not right. This one's not right. That one's not right. So I already know my answer is A without even having to do range. But we're going to do range as well, just so you can see it. Range is talking about start from the bottom. So we're going to start from down here, and we're from negative infinity, and we're going to come up here and we're going to go up to positive infinity for Y value. So I'm looking at the numbers here. So all the Y values coming up here are working, and then I get here and it doesn't work there. So it doesn't work right there, and there's no dots anywhere from there to there. So it doesn't work from there all the way up to there, because there's no dots in my graph right there. So from -2 to -1, nothing works. So it goes from negative infinity up there to -2. So when I do my range, I'm going to go start at negative infinity. As I'm coming up, I get to -2, and it does not work. So that is a parenthesis. And then all these numbers don't work all the way up, including to -1 doesn't work. So I can now jump not just over -2, I got to jump all the way up to over -1. And then if you see this thing's going up, everything else is working. So that is -1 to infinity. So that's what this part says right here. So I checked it, and that is the right answer. Let's see, 9, 12. Number 10, we're going to do number 10 now. So number 10 on the practice tab, I'm going to erase this so I can see it better. Find all values such that f of x is 0. This is asking me to find x intercepts, because that's y equals 0. So wherever y equals 0 means I'm finding x intercepts. So I'm supposed to take and plug 0 in right there. Well, I'm going to come up here and do this. So I get 81 x squared minus 49 equals 0. Now there's more than one way to do this. And if you want me to show you both ways, I will, but I like practicing factoring. So I'm going to factor this thing because this is a difference of squares. So the square root of 81 is 9x. I'm sorry, 81x squared is 9x. So 9x goes here and here. 1 is a plus, 1 is a minus, and the square root of 49 is 7. So then you're supposed to take 9x plus 7 equals 0, and 9x minus 7 equals 0. So over here, you subtract 7 over, and then you divide by 9. So you get -7/9. Over here, you add 7, and you divide by 9, and you get 7/9. So positive and -7/9 work. So right there's my answer. There is another way you could do that. I'm going to go ahead and show you. This is not the case with a lot of problems, but when there's only an x squared, you can do it this way. But a lot of people forget to put plus or minus doing it this way. So that's why I like factoring, because you find both answers right away. So you can also take and add 49 over to the right side. Then you can divide by 81. And then when you square root both sides, you got to remember on the number side, you got to put a plus or minus. People forget to put the -1 and they leave 1 off. And so the square root of 49 is 7, and the square root of 81 is 9. Anybody got any more questions on this particular problem? Okay, somebody asked for 6 and 7 on the trail walk, which is great because that's a domain problem, and you guys have been having trouble with domains on the quizzes. And you can come in on the quiz and get your quiz first thing Monday morning and Tuesday morning. And then you can go and look at your problems. So anyway, we want to find the domain. So whenever you think of domain, you always want to at first anticipate that it's going to be everything. But if you ever have a denominator with a variable, it's not going to be this. This won't work anymore, because as soon as you see a variable in the denominator, you are not allowed to take a fraction and divide by 0. We don't even care. It does not matter anything about the top for domain. This x plus 3 is worthless for domain. All we're worried about is what will make this bottom 0, because you're not allowed to divide by 0. So you are supposed to take the bottom and set the bottom equal to 0. Now this is a quadratic. Some of you, it is against math law to take this 3 and move it over to the other side. If you do that, you are guaranteed to miss this. You always have to have a quadratic equal to 0 when you factor. You can use quadratic formula if you remember it, but we are supposed to know how to factor. So you're supposed to go 2 groups of parentheses, and you're supposed to factor this to x minus 3 and x plus 1. Now, does anyone need me to go over where that came from, this x minus 3 and x plus 1? If I see a yes, I will tell you where that came from. Does anybody need me to do that? Okay, so now you take each factor and set each factor equal to 0, and you solve for them. Okay, do you remember the graph we just did a minute ago? The graph we just met a minute ago where we went from left to right and there was that value that did not work. I think it was -2. Well, these two values don't work because you cannot let this happen because it makes the denominator 0. Look, if I plug 3 in there, 3 squared is 9, -2 times 3 is -6, and 9 minus 6 is 3, minus 3 is 0. You can't use 3. If you plug -1 in here, -1 squared is 1, -2 times -1 is +2, 1 plus 2 is 3, minus 3 is 0. That's why it can't be those. You are not allowed to have 0 in a denominator. So just like before, when you're describing the domain, we always start way out to the left. So if I'm thinking about a number line coming across here, I'm starting out here at negative infinity, and I'm coming along this number line, and I'm looking, and the first number I come to on the number line, the smallest one out of these two is at -1. Well, I know this does not work. And then as I come over here, I know that this does not work. And then going this way, everything works the rest of the way. So I have to come up here and I got to say, well, it works from -infinity to -1. And now I have to jump over just the -1 because that's the only value that doesn't work. And then I'm going to follow -1 works all the way up to here to 3. And then I have to jump over that 3 because 3 doesn't work. I jump over it and then I finish at infinity. So that is this domain. Now the next problem I'm going to do is very similar to that one. Okay, so we're going to come over here and do number 7. Very similar problem. But because there is a variable down here. Also on this one, you have a radical. You are not allowed to have a negative inside a radical. So I know that x minus 2 cannot equal 0. So that means x cannot equal 2. I also know that x plus 3 has to be greater than or equal to 0. So x has to be greater than or equal to -3. Okay, so what that tells me on a number line, this thing right here says the furthest left I can start is -3. And then I get a problem when I get to +2 on my number line. So -3 works because it can equal -3 because that gives you 0 and you can have a square root of 0, which is 0. And then you can go this way, this way, this way. And then this does not work because you can't put 2 in the bottom. That gives you 0 in the bottom. And then anything else going that way works. So this domain is going to be -3 with a bracket because -3 works, going to 2 with a parenthesis, and then a union. You jump over the 2, and then you go to infinity. Now, that is a pretty tough problem. Does anybody have a question on that one? Anybody? Okay, does anybody have any more problems you want to see off of anything to get ready for your tests? Because when you come in here Monday and Tuesday, I'm not going over questions, I'm doing them now. So those people that did not come to Zoom are going to be out of luck. Also, I'm going to collect the trail walk, I'm going to collect the practice test, and I'm going to collect anything else I have not collected in your classes. If you have not finished Khan Academy, you have until tonight to do that. And if you go back in and you redo Khan Academy, I need you to shoot me an email. I've had 5 people email me and I went back in and changed their grades. So if you do that, you need to come in and go over that with me. All right, I got 2 more trail walk questions, I think. Oh, wait a minute. Why wouldn't it be negative infinity? All right. Someone asked, why wouldn't it be negative infinity? So let's say I pick -4. I pick -4. If I put -4 up here in the top, isn't that the square root of -1, which you're supposed to know means imaginary? Imaginary numbers don't work. That's why I can't go to the left of -3 because it makes Mr. Downing's friends. They're not real. So you can't pick anything over here because it makes this top part imaginary. Does number 2? No, number 2 does not equal itself. All right, I'm going to do number 8 and 11 on the trail walk. Do you want number 2 also? If you want number 2, tell me while I get this number 8 and 11 up, pictures of them. Okay, I'm going to do 2, 8, and 11. So I'm going to do them in order. Oops, that's number 1. And 11. All right, so I'm going to start off with number 2, and then we're going to go from there. So this says, what kind of symmetry does x squared minus 12 have? So when I do this problem, I'm going to check x-axis first. And when I check the x-axis, that means xy and x negative y have to give me the same equation when I plug those in. Well, this equation right here is the xy, the original point. So all I got to do is get this one. So this says, well, hey, I got to change the sign on y. So I put negative y in there, and the x sign stays the same. They're both regular x, so I leave this right side the same. And then when I solve for y, I multiply each side by -1. That gives me negative x squared plus 12. And I look at this equation and the first equation and ask, are they identical? And the answer is no, that does not work. So then I do the y-axis. The y-axis says that not only will the original equation work, but it should also work if I change the x value and leave the y the same. So now I'm leaving the y the same, so I leave y. And now I got to put this negative where that x is. So I get negative x squared. I plug that negative x in for that. Now when you square a negative, I hope you all know that's a positive, and I get x squared minus 12. So now I look, is that the same as that? Yes. So the y-axis works. And the last one you're supposed to check is the origin. Well, I'm going to show you a little shortcut now. The origin says not only does xy work, but negative x negative y work. Well, didn't I just do negative x right up here and get this answer? So what that means is I get a negative y over here. And if I already know this because I plugged it in up here and it will always be this way, I can go ahead and say, well, that's x squared minus 12 because that's what negative x does. And then I multiply by -1 and I ask myself, is that the same answer? And the answer is no. So this is only symmetric to the y-axis. Next problem says, yes. I can later, I'm zooming right now. All right. Okay, bye. All right, so I got somebody else wanting to join the meeting a little late. Okay, so we want to get the domain and range of this thing. So domain is left to right. This thing is going wider, which means it's going to end up going out there forever. And this thing keeps going wider that way, which means it's going to go that way forever. So as I'm coming along this way, all these, because this thing keeps going forever that way, and this thing keeps going forever that way. As I'm coming along here, I'm looking for, are there any X values that don't seem to work? Well, I can get right here and look, there's an open circle there. But there's a filled in circle there. This filled in circle means 3 negative 4 works. Because filled in means it works. This means it doesn't work, but 3 works here. So since 3 works there, it continues to work the entire way because there is a 3 value down here. So on this problem, the domain is negative infinity to infinity because every X value is on the graph. There's no X value that doesn't work. Range is bottom to top. Well, this graph goes down forever. So coming down here, this is negative infinity. Coming up here, I'm going to positive infinity. And if you look up here, this thing keeps going up forever. So as you start at the bottom, as I start at the bottom, I am starting at negative infinity. And I am coming up, and I'm coming up, and I'm coming up, and I'm coming up. And this is not real cool. This is not good. I should have had a -2 right here. So I hope you can see. Oh, wait a second. I got to back this back up. I don't need that -2. I get to here, and this dot's filled in right there, right? And then this is a dot on this graph right here, but nothing is working between these. There is no graph. It goes from there, jumps up, but it comes back down here. So all these work, and they work going up, but nothing works from here to here. So -4 is filled in. So that means I'm going from negative infinity to -4, and it's filled in, so I need a bracket. And then it jumps, so I need to say and. Well, the next lowest value it gets to is right there at -3. So then I get to put a bracket here, and -3 works because that point is on the graph. And then every point going up works forever to infinity that way. So that would be your range. Again, that is kind of a challenging problem right there. Those domain and range ones are not always easy. And then I'm going to do number 11, I think is the next one. Yeah, I think this is the last one you guys have asked for so far. We want relative mins and maxes. Mins are bottoms. So this thing right here is at the bottom. So this is a minimum. And this thing right here is at the top. So this is a maximum. Because we are only looking at it in this area. So these are called relative min and maxes, but it doesn't matter. So I need to get this ordered pair. So to me, it looks like to me that that's at that 3 and -3. So my minimum is 3 because X comes first, -3. And my maximum, if the X is first, that looks like it's a -2. I get left 2, and then it looks like I went up to +2. That is my max. Now it says I also want x-intercepts. Well, x-intercepts, here's your x-axis right across here. I want to find the places that graph is touching the x-axis. So my x-intercepts are x equals -4, 0, let's see, 4, 5, 6, 6. So there's your x-intercepts. So there's your minimum, your maximum, and your x-intercepts. X-intercepts mean where the graph crosses the x-axis. Are there any other questions you guys have on anything? Okay, can you go over number 3 on mini quiz 1.2? All right, oh, you put the problem down, okay. It said use algebraic test to check symmetry to the origin. Okay, so I want to show you something. If you recall, a minute ago, I did these, right? I'm going to do this exact same thing that I did for checking symmetry with this one. I got to check x-axis, y-axis, origin. So I'm going to plug in this point for x-axis. I'm going to plug in these letters for the y-axis, and I'm going to plug in those letters for the x-axis. So I got to find that quiz real quick. You said it was on 1.2, number 3. Okay. I got that problem up here somewhere too, so let me find it. Oh, better yet, that problem's on the first video I'm going to post here in a few minutes on period 1. So you can go to period 1 and find that number 3 and check out that first period review questions. Can you do number 1 and 15 on the trail walk? I'm pretty sure I did them right, but want to check because I messed up somewhere. Okay. I'm going to do number 1. Then I'm going to do number 15. Gotta move that over some more. Number 15. Okay, I'm going to go ahead and do this one first because it's on there. So hopefully you all know that this is going to be a quadratic equation because it's got an x squared, which means it's going to be a parabola. So it's going to look like the arch from St. Louis when we're done, or an upside down arch from St. Louis. This is going to actually look like the arch, but anyway, here we go. I'm going to do my y-intercept. I'm going to plug x equals 0 in. So when I do that, I get negative 0 squared plus 2. So I hope you know the y-intercept is going to be at 2. So when I start graphing this, I go up to 2, and there's going to be a dot right there at 2, y-intercept. Then I'm going to get my x-intercepts, which means I'm going to plug y equals 0. I'm going to get 0 equals negative x squared plus 2. I'm going to add x squared over to the other side. That way I get rid of the negative right away. And then I'm going to square root. Well, the square root of 2 is somewhere approximately around 1.41. So I'm going to go over here. There's 1. There's 2. Somewhere in this area. Oops, let's go blue. And then same way going the other way. Negative 1, negative 2, somewhere in here. Now that would be enough to graph this because you know it's a parabola. Now you could, I know there's one problem I think says put 5 points on it. Right now I've got 3 points. So you can do an x and a y. Now I plug 0 in. Sorry, I plugged 0 in for x and got 2 out, so I already know that's a point from right here. And then when I plugged in y for 0, I got 2 answers out. I got a radical 2 and a negative radical 2, so there's 3 points. Now I can just pick another number. Let's go ahead and just pick 2 and negative 2. So if I put 2 in here, that's 4, which is negative 4 plus 2, that's negative 2. If I plug negative 2 and square it, that's 4, and then negative 4 plus 2 is also negative 2. So you can go over here to 2 and come down to negative 2, and over here and come down to negative 2, and get more points. You can put as many points in this x value as you want to put in to graph all those points. Okay, I'm going to go on to back to do number 1 here. It says find the x and y intercepts of this function. So I'm going to do what I just did a second ago. I'm going to say, hey, I'm going to get the y-intercept by plugging 0 in for x. So when I do that, I get y equals the absolute value is 0 plus 1 minus 3. 0 plus 1 is 1. Absolute value of 1 is 1. And 1 minus 3 is negative 2. So there is my y-intercept. For my x-intercept, now this one's a little harder, so I'm going to move this up a little bit because it's absolute value. When you do the x-intercept, you get y equals 0. So again, I'm going to plug 0 in for y. And I'm going to do this deal over here. Now, I've told you on absolute value, you have to get the absolute value by itself first. So I've got to take this 3 and add this 3 over here, because you want the absolute value part all alone. So you get this. And like I've shown you in class multiple times, the absolute value of -8 is 8. And the absolute value of +8 is 8. In other words, you can put a negative and a positive of this value in here and get the same answer out. So that means out of x plus 1, you can put a negative x plus 1 in there. That has to equal 3. And you can put a positive, I don't need a parenthesis for positive. You can put a positive x plus 1 in there and equal 3. Either one of these work. Now I'm going to multiply each side by -1 to get rid of my negative on the right or the left side. And then I'm going to subtract 1 over. So one x-intercept is -4. And over here, you're going to subtract 1 over, and the other x-intercept would be 2. So there's your x-intercepts. Okay. Does anybody else have anything you want me to do for you to show you how to do something on this? Anything? Because we are having the test Monday and Tuesday first thing. If I don't have any more questions, we're going to call it a day. All right. Well, I hope you have. Oh, I want to make sure you all hear this because somebody came in late. We're testing Monday, Tuesday, first thing. I am collecting the trail walk, the practice test right when we start, and then I'm passing out the test. If there's another thing I have not collected in your class that we've done for homework, I'm going to do that. And you have until 11:59 to finish Khan Academy. Again, when you're done with Khan Academy, send me an email so that I can go in and get your grades updated so that I know you've done it. So please, and I will try to get that done before the weekend. So have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I will see you guys Monday. Do we turn in? Yes. You have to turn in anything you have not got a grade for Monday if you're here Monday. If you're here Tuesday, you have to turn it in Tuesday. I will not take any late work over this first test after the test. So everything has to be turned in that you have not turned in before the test. And I want you to hand those things to me that are late, separate from the trail walk and the practice test, so I can make sure I get them in the grade book correctly. All right, you guys have a great weekend. Do what's right, not what's popular, and I will see you guys on Monday and Tuesday.